This film presents stroboscopic laminagraphy, a new research methodology for studying laryngeal function. By means of this technique, the vocal folds may be seen vibrating in coronal cross-section. First, you will see the device, Stro, that provides stroboscopic laminograms. Then you will see the vibrating vocal folds. This is the first device of its type in existence. This is the control system for Stro. On the right may be seen a standard X-ray control panel. On your left is the panel on which are placed the controls for specific functions that provide for stroboscopic laminography. Actually, Stro is quite versatile. It can provide standard X-ray, fluoroscopy, standard laminography, continuous laminography, and of course, stroboscopic laminography. Here is the heart of Stro. In the center is the yoke and boom arrangement with its mounting and counterbalance. At the right is the X-ray generator. At the left, the pulse tank. Now look at the two arms of the yoke. The X-ray gun is mounted on the lower arm. The image intensifier and its cameras on the upper arm. Seen in place are the TV and 35mm cameras. These can be shifted automatically. As stated, Stro is quite versatile. It can be adjusted in a number of ways to allow convenience in operation and subject placement. Moreover, it can be operated in several modes in order to provide a variety of X-ray techniques for research. Here the whole system is being lowered. In this sequence, it is being shifted toward the subject. It will be remembered that one of Stro's important functions is that it can make many laminograms in rapid succession. Here, continuous laminography is seen. At the end of a sweep, the film is advanced a frame, a laminogram made on the return. Another advance a sweep, another laminogram. This is repeated until the desired number of films are obtained. A phantom is seen on one of the TV monitor screens. The letter F is at the laminographic plane. The other letters above or below it. The details of Stro's control panel may be seen in this sequence. Available are controls for subject frequency, brightness, output level, and so on. Also available is a technique switch that allows selection from among any one of 12 different operating modes. Stro operates quite simply. The subject's steady sustained phonation is passed through a filter which extracts fundamental frequency. The signal is fed to the pulse tank, which flashes the X-ray gun at the same frequency the subject is producing. A 250 microsecond pulse is used. In the most common operational mode, a laminogram is made as the X-ray is pulsed. By this procedure, the image of the folds in one position is obtained. At the end of the sweep, the film is advanced a frame and the pulsing shifted 36 degrees out of phase with the voice. Another laminogram is made. Thus, in 10 sweeps, films are made of the folds in 10 different positions throughout their vibratory cycle. This sequence will show stroboscopic laminograms being made. The subject is placed on the table, positioned, and secured. The microphone with probe tube is positioned. The subject position is checked on a TV monitor. However, determination of the proper laminographic plane is not shown in this sequence. The 35mm camera is shifted into place as the subject phonates. A signal is given when the desired phonational conditions are observed. At that time, an engineer makes the final adjustments and sets Stro into operation. A series of 10 stroboscopic laminograms are being made. If a satisfactory series of X-rays is to be obtained, the subject must continue phonating at the specified vocal frequency and vocal intensity for this whole period. In practice, however, it has been found that subjects can be trained to do so easily. This drawing of the larynx in coronal cross-section will be used as orientation for the films to follow. The superior portion of the trachea is seen at the bottom of the drawing. Above it, the folds are seen projecting into the airway toward the midline. Immediately above them are the ventricular spaces extending laterally. Next, the false folds project mesially into the airway and top the pharynx. This sequence shows the vibrating vocal folds of a human subject. They were made by photographing prints of 10 stroboscopic laminograms, 4 frames per print, on 16mm motion picture film. Since this series was one of the first made, the contrast levels varied from picture to picture. In an effort to equalize definition, shading was added to several of the prints. However, in no case were the outlines changed. The subject was an adult male baritone producing 100 CPS at a very soft vocal intensity. It must be pointed out that this sequence is shown only to demonstrate the research methodology, and observations of vocal fold action are hazardous. However, the complexity of vocal fold movement is apparent. The folds apparently are blown somewhat upward as they open and seem to thrust downward into the airway as they close. Also, it can be noted that only a small portion of the folds touch during the close phase. This sequence shows the vibrating vocal folds of another subject, an adult male baritone, producing very soft phonation with a fundamental frequency of 125 CPS. The action in this series of stroboscopic laminograms is somewhat different than that seen in the previous sequence. First, the folds do not appear to be blown upward upon opening. Second, in closing, there is a marked thrusting of the center portion of the folds horizontally toward the midline. Again, however, only a small part of the folds appears to touch on closing. Finally, the short closed phase for both subjects seems related to their very soft vocal output. A program of laryngeal research utilizing stroboscopic laminagraphy is being carried out at the Communication Sciences Laboratory at the University of Florida. The results to date are encouraging, and it would appear that this research technique will provide useful information about laryngeal function.